Hello. So today we're going to be talking about polynomial division. Polynomial division is the algorithm that's used to divide polynomials. Now, back in elementary school, we learned an algorithm for dividing just regular numbers, that long division stuff that we used to do. The algorithm for dividing polynomials is exactly the same algorithm, but we are throwing in like x's and different variables. Now, back when we learned the long division algorithm back in like elementary school or something, what we were trying to do is we were trying to take this number like, let's say, 8/3, right? You've got some sort of improper fraction. You want to write that improper fraction as a mixed number. So you've got the integer out front, and then you've got the fraction part of your answer. So what we did was we divided, we looked to see how many times does 3 go into 8. And 3 goes into 8, we've got 2 times, you got a remainder of 2, right? So when you wrote that as a mixed number, you had 2 and 2/3. What we're going to be doing with polynomials is the very same thing. I'm going to be looking at something that's basically an improper fraction with a polynomial, and then we're going to be writing it like a mixed number, this 2 and 2/3, with the integer part and the fraction part. Okay? So let's take a look at this. Basically what we're going to do here is we're going to look at a fraction, a rational expression that has a polynomial that has a degree that is greater on top than the degree on the bottom. So the degree of the polynomial on top, well, let's see, that looks like it's a 5. So you got a degree 5 polynomial on top, and on the bottom, in your denominator, looks like that's 2. So the degree in the numerator of this rational expression is greater than the degree in the denominator of this rational expression. So this fraction, this rational expression there with polynomials on top and polynomials on the bottom, is written as an improper fraction. What we want to do is we want to write it as a mixed number. So to do this, what you're going to do is you're going to take the divisor and you're going to write that on the outside, and then you're going to take the dividend and you're going to write that on the inside. So you're going to take the bottom part, the denominator of my rational expression, that's going to get written on the outside. Then you have the numerator of my rational expression, that's going to get written on the inside of my gazinte there. Now, when you do this, what we want to do is we want to write these, it's helpful to write them in standard form. Standard form being the highest degree going down to the smallest degree. So I rewrote this expression here so that I've got x to the 5th, that comes first, that's my biggest degree. And then you notice the exponents decrease as I move from left to right. The other thing that I did, which was interesting, is I took this, there is no x in my original equation. So I used that placeholder there to write a 0x. Now, you don't have to do that. It's not absolutely necessary when you're doing this algorithm, but what it does is it actually lines up all of your variables so it's nice and easy when you're doing the division. I find it super helpful, and you can do it if you want. Okay, now, remember when we were doing long division, we were looking for how many times does this number on the outside go into the number on the inside. That part is exactly the same. I'm looking for the first term on the outside. How many times does this first term go into the first term on the inside? So I got to find something to multiply x squared by to get 3x to the 5th. What do I multiply x squared by to get 3x to the 5th? That would be 3x cubed. So what I'm going to do, the number that's going to go up here on top is the number that you multiply by this in order to get this. So it's the 3x cubed. What I'm going to do is I'm going to line up the 3x cubed with the x cubes underneath, right there. Again, that's just to help line everything up. It's to keep track of things. So you get the 3x cubed on top. Now I got my 3x cubed on top. What I'm going to do now is I'm going to take the number that's on the outside, and I'm going to multiply it by all of the terms on the outside, and then I'm going to write that expression underneath just like I would with long division. So I've got 3x cubed times x squared. That's going to give me my 3x to the fifth. That's what we want. We want those two terms to be the same. Then you've got the 3x cubed times the 4x. And that's going to be plus 12x to the fourth. Notice how I'm lining up the variables that have the same exponent. That helps me keep track of where I am. Now, just like with long division, after you did that multiplication, what you did was you subtracted the term on the bottom from the term up top. I'm going to do the same thing. I'm going to subtract this entire polynomial from that piece right there. Now, the thing you have to pay attention to when you're dividing these, when you're subtracting them, is that that negative sign, when you're subtracting, gets distributed to everything on the inside. So this negative applies to that 3x to the fifth. That negative also applies to the 12x to the fourth. One of the most common mistakes is to forget to distribute that negative. We've got to remember that negative. So when you subtract these things, 3x to the fifth minus 3x to the fifth, that's going to be 0. Those terms go away. That's what we want. We want to decrease the exponent as we go. Then I've got 5x to the fourth minus 12x to the fourth. 5x to the fourth minus 12x to the fourth is going to be negative 7x to the fourth. And then what we're going to do is the exact same thing that we did with the long division algorithm from back in elementary school. We're going to take the next term and bring that next term down. So I've got minus 29x cubed. And then after I brought that term down, I'm just going to repeat that exact process. I'm looking for what do I multiply my x squared by in order to get negative 7x to the fourth. So that's going to look like negative 7x squared. And again, I'm going to write that up here, minus 7x squared. It's above the x squareds just so that I keep all my variables in a line. Helps the organization. Then I'm going to take that negative 7x squared and I'm going to multiply it by both terms on the outside and write them underneath. So I've got the negative 7x squared times the x squared. That's going to give me my negative 7x to the fourth. That's what we want. We want those first terms to line up perfectly. Then I've got this negative 7x squared times the 4x. That's going to be negative 28x cubed. Again, I'm stacking my variables that have the same exponent. And then I'm going to subtract, just like I do with that division algorithm. And I'm going to subtract both terms, not just the first one. They're both in parentheses. You got to distribute that negative to both. When I do that, the first terms go away just like they did before. Again, decreasing the exponent. Then I've got negative 29x cubed, subtract a negative 28x cubed. So that's going to be plus 28x cubed, which turns into negative 1x cubed. Then I bring down my next term in the line. So that's going to be minus 4x squared. And I'm going to repeat the process. X squared looks like it's going to be minus x. So I'll put a minus x up here. And then negative x times the other two terms there gives me a minus x cubed, which is what I'm looking for. And then negative x times negative 4x is going to be minus 4x squared. Then I'm going to subtract those terms. Subtracting those terms, the first two terms cancel, just like we want. In this case, the second terms also cancel. That happens sometimes. That is a coincidence with the way that this is structured. It doesn't happen every time. But I've got negative 4x squared minus negative 4x squared. That's going to be 0. So just to keep everything straight, I'm going to write a 0x squared. That just helps me. You don't have to write it if you don't want to. You could just put a 0. And then I'm going to bring down this next term. That plus 0x. Now in this case, I'm looking for a 0x squared, which means the next term that I'm going to multiply here by is going to be plus 0. Plus 0, again, you don't have to add it on, but it helps me to keep everything organized and lined up. And then when I do that, I know that that's going to be 0x squared plus 0x. Again, subtracting all of that. That's just going to be 0. All that stuff goes away. And I bring down the plus 3. Now, look at this term right here, this plus 3. That plus 3 doesn't have an x on it. The exponent on this one, on that 3, is smaller than the exponent that's up here. Basically what ends up happening is once I hit a number down here that has a smaller exponent than the polynomial that I'm dividing by, the polynomial out here, I know that I've reached the end of my polynomial division. The degree of this term has to be smaller than the degree of that term. Now that I've reached that point, this plus 3, that's my remainder. I know that is my remainder. So I have the polynomial that is my result. That stuff right there. That's like the 2 out front of this one right here. That's like my integer part. That's the polynomial that results that doesn't have a denominator. So that is going to be, it looks like we've got 3x cubed minus 7x squared minus x. And again, I'm not going to write the 0 in this case because now I'm just adding 0. I don't need that term. And then just like we did with the division algorithm, I'm going to take my remainder and I'm going to put it over my original denominator. My original denominator being that one right there, the x squared plus 4x. And I'm going to add that on. So I have plus 3 divided by x squared plus 4x. And you'll notice that the degree of the numerator in my remaining fraction is smaller than the degree of the denominator. Just like with a proper fraction, the number on top is smaller than the number on the bottom. Polynomials deal with degrees, fractions deal with just regular numbers. So that is my final answer.